The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show. In a previous episode, we began work on the Sega Dreamcast Portable. We took apart the Sega Dreamcast, we figured out how to get it working with our bench power supply, we found the voltages, and we modified a PS1 screen to work at a lower power consumption so we could use it with the portable. In today's episode, we're going to continue the project by shrinking down the CD-ROM drive assembly and making it as small and compact as possible, adding a custom heatsink to the two chips, and figuring out where to put the batteries, the controller, and everything else. Basically getting a form factor figured out. Let's get started.
Amazing builds, exclusive mods, cutting-edge ideas, electronics, engineering, and more. Every week on Element 14's The Ben Heck Show.
One of the biggest challenges with making an original hardware Sega Dreamcast Portable is getting the CD-ROM section smaller. The systems that were kind of small and stacked, such as the Dreamcast and the GameCube, they tend to have thicker components. They weren't spread out like with the PlayStation 2, but I think we can do something with this. Let's take it apart and see what's inside and figure out how much smaller we can make it. So what I want to do is make this as small as I can. I mean, I don't know how much smaller I can really make it. This would go like this. Bring this together here. Can't really make this much smaller unless I move the motors, which isn't a good idea. And the head still has to be able to move back and forth to read the disc. And we still need to heat sink this motor driver. So we can't go too hog wild with breaking it down because we still need some thermal mass in there. Yeah, and plus we have these capacitors which are also adding to the thickness. The connector I'm not so worried about. I think we can redo that. Let's mock up what this might look like. CD drive driver, upside down, screen, controls that go on the side. Man, that's still a lot of stuff. It's kind of thick. I can reduce it somewhat, but I'm not sure if I can really get it that much thinner, but I'll try. Something to think about with this. This kind of makes it look like it would be like a portrait unit, you know, where the screen's here and you got the controls here like a Game Boy. Thinking landscape is probably a better way to go. This kind of fits the form factor better. Have the controls here. Yeah, that could still work. This board drives the CD-ROM. I want to make it a little bit more flush with the rest of the case, because as is, it sticks up pretty far. I think we could achieve some height savings here if we remove some of this shielding, maybe put the heatsink over to the left instead of the right, and the big thing is redo this connector. I actually tried this once years ago with the Dreamcast and just kind of gave up on it, but I'm not going to give up this time. Yeah, so I think that's what I'll do. There's a little shield here. I want to keep most of the shielding, but I want to reduce it and make it a little bit more compact. It's a lot of work to save 1/4 of an inch, but you know, it's worth it. All right, time to start the boring process. I'm going to heat up the pads on these connectors and slowly bend the connectors over to remove them from the motherboard. I do this slowly so I don't rip up the pads because that would be bad. I'm going to use Ultra ATA ribbon cable to make these connections. It doesn't carry a lot of current, however, a lot of them are duplicated, such as multiple powers and grounds, so it should be okay. I will tape the two halves next to each other so I can fold it open like a book and make sure that everything stays straight and level as I do all of these boring little connections. I need to make sure I do this right the first time because if you open and close it too often, it will cause the copper to eventually break, but it works pretty well in the end. The goal here is to have the minimum distance of wires so when you fold it together, it doesn't take up much room at all. Wow, I wish I could solder that fast, that'd be cool. I've used this Ultra ATA cable to connect the first half of the CD-ROM to the motherboard. A lot of eye strain involved with this, but it looks like everything's working. I'll just make sure there's no shorts. For the second half, I'm gonna go from here to here, and I need to wire this in a way that it can fold together but also be taken apart. Now to wire the other half. Eye strain city. Even more so than the outer wires, I have to make sure these inner wires are the right length, because when I fold it over, if they're too long, the outer wires will compress on it and the unit won't fold together the way I want it to. I'm just taking my time, making sure all the connections are good, double checking everything, and just, you know, it's kind of fun in a relaxing, mindless work sort of way. I've completed the wiring between the main motherboard and the CD-ROM drive circuit. I have flat ribbon cable here. And I don't want to do this too many times because eventually it'll break, but the idea is we can fold this over like this and have a fairly low profile system. And then what I'll probably do next is sneak in some heat sinks this way onto the two main chips. But this will give us a lot thinner system than we would have had otherwise. I'll probably also make a 3D printed mount, so this board will interface to the bottom board with a custom 3D printed spacer. And I'm gonna nestle these capacitors between each other so this is as flat as possible and still have room for a heatsink on the two chips. Because it's not necessarily about having a big heatsink on the chips, it's about getting some metal on the chips and then pulling the heat away. And you know, they're not that fast, they're not gonna be that warm anyway. Here are the 3D printed pieces that we're going to use to support the DVD motherboard. So I picked a height of 0.275 inches for spacing. That gives enough clearance for everything. And we'll bolt to it from the top and then also attach it from the bottom. That should make it pretty sturdy. We might use these screws for something else as well, for the support once we have more of a case around it. For now, it just proves that everything fits. The 3D print keeps everything consistent and makes it like a all one package. So instead of being two motherboards randomly connected through a bunch of wires, they're like one cohesive unit again. Yeah, that worked out pretty well. Everything's an even distance. You can see where our connections are. They're still here. There's a gap for them, so they're not perturbed. And I left a gap here so that we can mill an aluminum heatsink, slide it in place, then have it flare out this way so there's more surface area to pull heat off of the two main chips. Let's see, so this, we might be able to break this down a little bit more, but this basically goes here. All right. So we've basically used this to reduce the overall thickness of the unit and also keep it consistent and flat. All right, looking good so far. Next, we need to make a heat sink for the CPU and GPU. I have a little bit of clearance between them and the DVD board here. So I'm gonna measure it in the computer and make a paper pattern to make sure that I have their positions correct. Let's make sure this fits. The heatsink will mount to these two screw posts, and yep, looks like my measurements are correct. Paper patterns are a great way to test things out. Just print out line drawings in paper, cut holes in them, and reference all you want. On the computer screen here, you can see the location of the heatsink, the two main chips, and a lockdown tab. This will be like a little tab of metal that goes across, and we'll hook it down, and that will hook on the other side of the motherboard to make sure it's got a good pinch on the two components. This thing isn't gonna get super hot, but it's supposed to have a heatsink, so we're gonna put one on. This shows the layers. We have a lot of this 080 aluminum laying around, so we'll use that, and it actually adds up pretty nicely. 3 layers of 080 aluminum will stay underneath the DVD drive, so it should fit without any trouble. So what we'll do is we'll make 2 layers or 2 pieces that look like this piece, and then we'll cut one spacer that looks like this. And then we'll stack them up and use the thermal pads and Arctic Silver to attach the heatsink to the chips. I'm gonna cut some 080 aluminum and make a 3-layer heatsink. Cut out pretty well. Okay, we'll clean this up and then we'll take a look at the pieces. put together the layers of the heatsink. This piece goes down first. This piece goes over it. And this is what actually contacts with the GPU, CPU. Now I gotta hook this thing over. I don't want to bend up this disk drive controller any more than I have to. And so now we have a hook around the back. We have a hook that will hold it down when we compress it. So if we didn't have this, this might lift up, so this helps to pull it down. Let's make sure the screws go in, and then we'll go from there. I'm trying to decide if I should use Arctic Silver or the original pads. There's more of a gap here than here, but I'm kind of hoping the pads would compress out to make up for that. I also don't want to move this around more than I have to, because if I move it too much, eventually the thin wires will break. I'm going to try to make this work using the existing thermal pads that were on the Dreamcast. I've heard you can run the Nintendo 64 without any heat sinks, but this is a newer system, so I'm not going to risk it. I don't trust rumors. I only trust my own two eyes. Then I don't even trust them. I'm not entirely sure that I'm happy with the amount of compression on the two chips. I think what I need to do is turn one of these spacers into a thinner spacer. So instead of 080, probably like 063. So that sounds like a job for the laser cutter. I added a copper spacer underneath the heatsink because these two chips are not quite the same height. Let's see how it fits. The arm will add pressure as I bolt this down. See how it pulls the heatsink down onto the chips? I'm gonna shine a light through this and make sure there's no gaps. Oh, we can make a J.J. Abrams movie. We've got to get to the warp core! All right, this is looking pretty good. I think I might want to add a little bit of pressure here. So I think I'm gonna 3D print a clip, just to add a little pressure here to make sure the CPU is connected properly. I put everything back together and I'm gonna see if it still works. So we've got the custom heatsink and the hand-wired CD-ROM driver board. Let's see what happens. It appears to boot. Okay, it's missing the date and time, but it seems like it's booting up. Not sure how much heat these chips actually put off. It can't be a lot. The cooling on this, I mean, there is a fan, but there basically was just aluminum attached to the RF shielding. I'm probably gonna take this fan and put it like right here so it blows air up off the heatsink and maybe come in at the bottom. Looks like the CD-ROM drive works. That's the important thing. If you remember, we had all those little connections that were fairly tiny, and also I've been moving this around, so I was worried some of them might break, but it looks like everything's working. So this is the base shape of the unit. The Dreamcast motherboard is basically square, not quite, but in this view we can see that the CD-ROM itself would not be centered precisely. So it might actually be better to orient it like this, because this isn't centered on this axis, but it is centered on this axis, because you want it to look nice. Like the CD-ROM is in the center, and then everything else branches from that. And of course, it has a certain size. So the problem with making this portrait is if you have your hands down here, there's gonna be so much weight on the top of the unit, it'll be like, you know, tipping over on you. So even though it'll be tough to do with the controllers, I think it's a lot better to have the controllers on the side. What I usually do first is I kind of mock it up. I always do it in pencil, and I figure out where things are gonna be. So we get about that much space on the side. And then same thing for the left. I cannot draw left-handed, so that kind of sucks. These we can curve, so you can see the size of the unit starting to take shape. Something else we have to, well, not forget about are the batteries. If you look here, there's quite a bit of space. So this isn't exactly the battery we'll use, but it's close. See how there's room there? So we could put 1, 2, 3, 4, 5, 6 batteries and tuck them in this channel here. Yeah, and then have the controls here. I think that can work. There's also the screen, of course. So we're actually kind of designing this from the rear going forward. So if this is a reverse view, that means your analog stick is there, your D-pad is there. Oh man, it's hard to draw left-handed. Your 4 action buttons are there, and then you probably put the start button here, and then of course there needs to be speakers. Probably put those probably either up here at the top facing out, or here if there's room with the batteries. That might work, putting them at 45 degrees to go with the curve. We'll also need the fan in there someplace, maybe like right here to pull air out. This is probably the best way to go, which means I have to figure out a way to split this controller. Kill me. For each layer of this, I'm adding something to a known element. So we have this driver board for the CD-ROM, and I designed a riser to put on that the CD-ROM itself will connect to. So when I drive these screws, they'll go through both layers, making everything nice and solid. Time to install the top piece. So again, just like the white pieces below it, it's 2 separate pieces, but they connect to the same thing, and that will add rigidity to the overall unit. So this screw is going through the black piece, through the PCB, through a washer, and into the white base. Now, hopefully we can put this in place. Let's just make sure everything lines up first. Okay, it looks like everything is the way it should be. See how it's got some spring to it? I'm gonna dust it off, put some lithium grease in it, and bolt it in. I also had to make sure that the head, when it goes back and forth, wouldn't hit any of these components. So I actually had to raise this up a little higher than I thought I'd have to. So we got about 0.5 inches of space here. But this whole thing will rest on these 3 spongy joints, so that should work. I will bolt some screws in. That's kind of redundant. And then it should be, in place. Okay, I'm feeling pretty good about this. I have it all mounted as one piece. The disk drive, motherboard, heatsink, it's all one module. And I think I'm gonna actually mount it horizontally like this in the unit instead of like this, because it's easier to center the disk if it's like this. Now this paper pattern represents the unit from behind, so the disk will be out the back. So now I need to think about the controllers. Oh, and this big black bar, that's the battery. So they're gonna actually fit right here. Now this is a Dreamcast controller. I personally do not like the Dreamcast controller. I think it sucks. It probably did not help the system. A lot of people like it, but I don't agree with them. So it uses Hall effect sensors, which are actually basically analog magnetic sensors. So when you move the analog stick, it moves a magnet around, and these 4 sensors detect the proximity and give you the values. They also used Hall effect for the analog triggers, and no other console did until the Xbox One, which also uses Hall effect sensors for its analog triggers. The trick with this guy is splitting it, or putting it on both sides, because if this is your unit, you're gonna have 2 things here and 2 things here. Plus we have to figure out where to put these memory units, which are very large. Another thing I don't like about this console. So I printed the paper pattern just to kind of wrap my brain around things, and if you look at it like this, the ends of this would fit in those spaces. The problem is, we have all this down here that we need to preserve. So even if you were to chop this, like maybe chop it right here, you'd still have to reconnect a lot of things. Although this would probably be the least damaging place to chop it. But then if you put a chop here, you gotta think, where does this go? On this case, this is gonna intersect where this is, so you really can't do that. You can't put it down this low because that's where the batteries are. Yeah, there's also external integrated circuits here and here. There's a pretty good chance these are some sort of ADCs, or analog to digital converter, for the Hall effect sensor going to the chip here. There is another option that I don't even want to really think about, and that is to remove this chip and make our own control board circuit, but although who knows, maybe that's simpler than trying to figure this all out. I'm certainly not going to leave both memory slots in. We're going to barely have enough room for one, so that's all the more we're going to have there. I should just build in the memory slot, because really, those modules are huge. I mean, look at this thing. It's enormous. Who thought this was a good idea? I guess Sega. And now they're no longer making consoles. Coincidence? Let's see what's inside this thing. I also have a nicer VMU, with graphics and whatnot, but we only have so much space to build this in. Dun, 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 dun. If I had to guess, this is probably some sort of microcontroller and this is the flash. Guess we could look up the part number. I mean, I'd rather just embed this someplace than have this big honking cartridge sticking in. So, you know, it basically have internal memory. You couldn't swap out the memory, but you could just erase it. You know, like all modern systems, memory cards, so lame. Right now, the Dreamcast is like a puzzle with its pieces scattered everywhere. One piece is the battery pack. So I need to kind of figure out what I'm going to do with this before I continue. Once I know the shape of all the pieces, I'll have a better idea how they go together. This, I'm still worried about the controller. I'm working on it, I just haven't figured out the solution yet. I bought this battery pack from allbattery.com, and it's 6 lithium ion cells, 3 in parallel, which gives us 7.4 volts at quite a bit of discharge. So this should power the Dreamcast easily. So I don't want to change the way these batteries are wired, but I do want to lay them out in like a long bar. So on the Dreamcast, it'd probably fit down here. I ordered a couple different packs to try, but this was the only one that was in stock. The other ones were out of stock. Remember in episode 1, we were able to power the Dreamcast with 2 of these cells, but once we added the screen, it was just a bit too much. So I'm gonna explore under here and see what I can find. Now this battery pack is charged, so I wanna make sure I don't screw anything up. Oh look, another one of those balancing circuits. So these 3 are acting as one cell and these 3 are acting as the other cell, I think. So if you think of it as like, you know, a 2-cell pack, which would be 7.4 volts because each cell's 3.7 volts. So it's like a 2-cell pack that's been tripled. Oh, this is all bolted together. Look at that. So it's 3 in, 3 out. So you have your 3.7, 3.7, 7.4 total. I guess one way to do it might be a little bigger than I thought it was gonna be. But if I took it and split it, so it was like, because if I split it into 3 pairs, it will be a lot harder to rewire. Yeah, I think I'll try to split it into 2 for starters. If you see any explosive sparks or anything burn my face, let me know. My original concept was to run 2, 2, 2 down this length, but it'd be a lot simpler just to hook it up like this. Now, the issue with that is if I put them here, it will add about a 1/4 inch of height to the unit in this direction. The alternative, which I probably won't do, is to make the unit portrait like this, but then look how tall it gets, see? So I'd rather stick the battery pack here. Yeah, that's probably the best bet. I'll get this wired up and then make it into its own little unit. The Dreamcast Portable is coming along nicely. We have everything built into a single modular unit now, and we started to figure out how to make the batteries work and the controllers and the basic form factor to tie it all together. Now, it's not going to be next week. The conclusion will be a few weeks from now, but I promise it is coming. Dreamcast Portable Part 3, the conclusion. So stay tuned and we'll see you next time. Oh, hi camera. We have completely different conversations than Allison and I used to have. So the big conversation we have is how much we did not like Star Trek Into Darkness. It's not next week! I'm gonna throw a car through a diner window for no reason. The inhibitor chip, it's gone. It couldn't inhibit his desire to throw cars through windows. I glued the 2 pieces together because it is blood. The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.